So before going into today's topic about battery management system, I just want to share you a scenario. Like every day you get up on one fine day, you just get ready yourself, and you just want to go for your office, or you just want to go for a department stores to buy groceries. You just take your two-wheeler, and now we are all aware of the electric vehicles, right? So if suppose one of the two-wheeler what you use is an electric vehicle, so you just take one of it, you start riding it, and you observe there is no traffic on the road, so you just try to throttle it to the maximum speed you wanted, and just you ride it for a few minutes, then you observe a signal there, and you just stop your vehicle, and you once the signal is green, you just want to turn on your vehicle, and you observe there is something wrong on your speedometer. It is displaying there is some fault, and the vehicle is not turning on. You are just stuck there, and you just observe some fumes coming under your seat. So what would be your reaction? What is the reason behind all this? Or how you could start your vehicle, and who is communicating with you that something has going wrong, and who is protecting you from that? So that is none other than a battery management system. So there is always pros and cons. So there is some extent a battery management system can protect the end customer as well as the battery from the abusive usages. So let's know what it is and how complicated it is and what is actually happening. So in this webinar, you will come to know about a glimpse of what are the current scenarios and the EV market. What is the comparison between buying an electric vehicle and the IC engine vehicle? What are the batteries and what it compromises of, and what is a battery management system, and what are its functionalities and the functionality components, like the hardware and software related to it, and what is a battery modeling, and why it is important to have a battery model in the BMS, and what are all the softwares to be made for having a BMS as a whole product that is productionable, and what are all the sets of skills and the tools you should be aware of, and how get the job opportunities based on this tools and the skills you have. As you are all aware, like there are few brands that are coming out with the electric vehicle, and in India it is expected to have at least 30% of the vehicles to be electric by 2030. And we already rely on other countries to get the lithium ion batteries, which are all this only source for the EV vehicles. So and as well, the safety board in US is urging for automotive companies to improve the EV fire response guides. Like if suppose what would be the how we can protect from the EV fires which are caused by the high energy lithium ion cells. So if you consider what are all the EV vehicles, so if you consider the four-wheelers, what are all available in the market, it is by Hyundai, they have Kona Electric, and it has a range of 300 kilometers for a single charge, and it can throttle up to 100 kilometer per hour in 9.3 seconds and can charge in 6 hours. So the capacity of the battery source is 39.2 kilowatt hour, and if you compare with the MG ZS EF, so it has a comparatively high battery source, and it has as usual the range is also comparatively high. So there is also two more models released by like Tata Trigger EV, and it is for 21.5 kilowatt hour capacity, and it has its own specs like battery cooling system and all. So the Mercedes-Benz has EQC version. It can go up to a range of 400 kilometer. So if you consider the two-wheeler market, we have Ather 450X, Bajaj Chetak, and TVS Ico. These are all few examples, and we also have Okinawa's Hero electric vehicles. So once we compare between an electric vehicle and an IC engine, like an internal combustion vehicle, normal, which is fueled by a petrol or a diesel. So why we want an electric vehicle? What is the benefit out of it, and what is the differences? So if we consider for the example like an Ather 450X and commercial scooter Activa Jupiter. So we just have a comparison over here, and this is all. Most of them is the data is at more appropriate, I think. So that's how self-calculated. So the capacity of the battery source is 2.25 kilowatt hour, and for the fuel vehicle, like IC vehicle, it is 255 cc's, and the fuel tank can go up to 5.3 liters. Whereas the mileage between the electric vehicle and the engine, on comparison with them, electric vehicle offers more mileage for a single charge, and the maximum speed it can at least go similar to the engine vehicles. So when it comes to the cost wise for fuel per charging, it goes like 5 hours to charge, and it can consume up to 2.25 units. So approximately for engine vehicles, it is 100 rupees per liter. Now, how frequently you need to refill in one day? So if you're a normal user, like you just go for office and come back home, you just need to recharge only once. And like because the mileage it can give up to 75 kilometers. So if you stay in a city and you just want to go for one day usage, then electric vehicle is more convenient. Then you come back home and you put it for overnight charging, and next day you just take it. And the power consumption it will take is less than, it's very less, like 2.25 units only for each charge. Cost for and durability wise, it is like battery have around, normally they give on average like 50 cycles for 3 years, and like 50 cycles of charge and discharge. And the engine life, it is we can expect for an ICE vehicle like around more like around 5 years, and above 5 years based on your usage. So, and the cost wise, how much we spend for each kilometer in an electric vehicle and an engine vehicle. Electric vehicle compared to be have a very less value, like 1.15 rupees, whereas for an engine vehicle it comes around 1.6 rupees for 1 kilometer. So though the investment for an electric vehicle might be huge, like it can be around, for a scooter if you take, it can come around 1.5 lakhs approximate on road, whereas for an engine scooter we just spend 60,000. So, but the cost of fueling, the maintenance cost and the usage cost for an electric vehicle is very less compared to an engine vehicle. So let's know. Let's also get a glimpse of what are batteries. So everyone will be very aware what a battery or what a cell has. A cell generally has an electrode, an electrolyte, and a separator. The electrodes are the positive and negative electrodes, like the anode and cathode will be there. They might be dipped in electrolytes with a separator, insulator. So while discharging and charging, the electrodes undergo a chemical reaction and they produce electricity. While there are two types of batteries, or a series combinations or a combinations of single unit cells in different combinations of series and parallel in order to achieve the required power and the energy requirements. So if you want a high potential, then you have to increase the number of cells in series, and if you want more energy, like you have to draw more current, then you have to increase the number of cells in parallel. So based on the requirement, it is configured for a series and parallels of cells. So generally the batteries are categorized into two types, like primary batteries and secondary batteries. The primary batteries are non-rechargeable and they can't be reused, whereas the secondary batteries are reused and recharged. So general purpose, once we take the into our day-to-day applications, we just make use of batteries in a lot of places. So this like the primary batteries we have everywhere, like in the clock where you see the time, and in the remotes which is used for switching the channels in the television, and everywhere you can see the primary batteries. But nowadays slowly we are moving to the secondary batteries, like it is all available in our day-to-day usages as like the primary batteries. Like from the smartphone we take and to the laptops we use, all the smart devices where we used to charge it and we use it. So all this have a secondary batteries, and most commonly they have lithium-ion batteries. So why we go for lithium-ion batteries, and what is more specific about choosing lithium-ion batteries? So we'll come to know about this in the coming slides. So yes, the common home appliances, and now slowly we are going into transportation with the high energy rechargeable cells. Those are lithium-ion cells. So in this, you can see from the small capacity to the highest capacity requirement of cells where we generally apply. So from the UPS or uninterrupted power supply services in the home, where we have a big set of lead-acid batteries, and though we have make use of batteries in that application, and we also have e-bikes even for the medical equipments and for the laptops and mobile phones. Even when the requirement goes big, the capacity required to be met also will be very big. Where let us consider you have a UPS backup in your home, and there is a battery source, and let us like it most commonly we make use of lead acid batteries, right? So let's compare what is the capacity of that lead acid battery and what would be the capacity of a battery in your laptop. So there will be a very huge difference, but in terms of size and the potential it made. See, one lead acid battery cell can give a nominal voltage of 2.1 volt, and it can have a capacity of 1 ampere hour. But if you consider a secondary lithium ion cell, it can have a nominal voltage of 3.5 volt, and based on the chemistries, and it can go up to maximum of 5 ampere hour of capacity. So like if you want to go for, in order to meet kilowatt hours of energy requirement, think of having the lead acid cells, how much big it would be and how much the space and the storage it would require if you go for a lead acid battery. So why we choose a lithium ion battery? The one of the specific reason, as I quoted before, it has a high specific energy. And before that, let us know about what compromises are. Lithium-ion batteries are also a secondary batteries, and they compromises of few additional set of components compared to other cells. Like they have a positive electrode, negative electrode, and electrolyte and separators similar to the other cells. In addition to that, they also have positive current collector, negative current collector, and positive terminal out and negative terminal out. They are all manufactured in a way that they take a sheet of positive electrode and they have a separator on top of it. They have a negative electrode on top of the separator, and then they roll the sheet, and it will be connected to a current collectors, and the terminals will come out. So this is how they are all made. If there is a very the gap between the positive electrode and the negative electrode is very small, as they are having kept together and they are very separated by a very thin sheet of polythene or polymer. So if there is a very small dust, like a small bud, what would be the case? How it could react? Obviously, it can conduct the current, high current can flow, right, resulting in thermal runaway. So this is one of the challenges in the high energy cells. So why we choose lithium ion cells, though this has one of the basic criteria to be considered as a safety, it is very it's very less safer. Still, why we choose a lithium ion cell? Because it has a high specific energy. They are more reliable. Like they can undergo thousands of charging and discharging, and has a wider operating voltage range. Whereas the high density cells, where chemistries like nickel metal hydride, they have a very less voltage range, operating voltage range. Like it can operate from 1 volt to 2.1 volt, or 1.5 to 2.1 volt. The maximum potential it can go up to is 2.1 volt. So if you want to have a 60 volt system, if you go with the nickel metal hydride cells, then you have to have the maximum voltage of a nickel metal hydride is 2.1. So if you want to meet 60 volt, then you have to have 30 cells in series. Whereas if you want to have use a lithium ion cell which has a nominal voltage of 3 volt, you just have to have 20 cells in series. Though then whereas in a nickel metal hydride the maximum voltage is 2.1, and in a lithium ion the nominal voltage itself is 3 and it can go up to 4. So if you take a maximum voltage of 4, then in order to meet 60 volt you have just to have 15 cells in series, whereas in a nickel metal hydride you have to have 30 cells in series. This gives it twice the space occupancy. And compared to other cells, the lithium ion cells have a nominal voltage to be comparatively high. So, do they undergo normal electrochemical reaction? What is a chemical reaction that it actually happens there? The lithium ion cells are undergoing intercalation and deintercalation of the lithium ions between the cells. Like from the lithium ions will move from one electrode to the other electrode. This is what is happening to produce the required energy. So while charging, you just give the electrons and it again moves from one electrode to the other electrode to develop the potential. So they doesn't undergo a normal electrochemical reaction. They undergo intercalation and deintercalation. Like in a set of layers of molecules of the lithium ion chemistries, it transports from the one layer of the lithium ion electrode to the other layer of the electrode. So there is a movement of lithium ion cells. So this is a general chemical electrochemical equation for charging and discharge. So reaction in the cathode is observed to produce lithium carbonate while discharging, and while charging it is decomposed to produce electrons and lithium ions. Moving on, what are all the general parameters to categorize, to specify or to define a cell or a battery? So first it is potential, like voltage. So any cell manufacturer give a specific set of specific values for a nominal voltage. Like if you take a cell, it has a capacity of 3 ampere, and they will mention it nominal voltage as 3.5 volt or 3 volt. So it is a potential it can maintain on average. And what is the energy? The energy can be it is nothing but the watt hour. So how long it can deliver the power. So that is what energy is about. And the specific capacity or specific energy, like for specific energy it is like how much energy it can give per unit mass. So how from 1 gram of material you can take more energy. So if the specific energy is low, like then you have to may have more weight. It adds more weight in order to meet the energy requirement. So energy efficiency, like charging and discharge efficiency, how much it can deliver to how much it can consume in order while charging. So how much energy it has been discharged and how much energy it has been consumed while charging. So that ratio gives you an energy efficiency. C rate is nothing is a rate at which you can discharge the cell to completely drain it out in 1 hour. So that is one C rate. There is a set of C rates will be available. Like you can operate the cell at a specific C rates. Like you can go up to 2C continuous in order to discharge it. Still, it will not undergo a thermal runaway, or it will be still stable. Like if you have a cell with a C rate of 3 ampere hour, you can continuously discharge it. If it is rated for 2C, it can continuously discharge for 6 ampere for 1 hour, and it will be completely discharged, and it is within the safer region. So Coulombic count is the how much charge it can provide or it can deliver. So as you all, it's a basic formula, like charge is the current into time. So how much current has flown for how much duration, that gives you the charge. So if you draw current 9 ampere for 3 seconds, so 9 into 3 gives rise to 27. So that is how that many coulombs of charge has been taken out. So that is Coulomb count. Then thermal behavior, there is a set of cells should be more specific, can't be operated at higher temperature ranges like above 60 degrees Celsius, above 50 degrees Celsius. Then ambient temperature can be anything. Like you can drive the vehicle even in Rajasthan, but the temperature of the cell has to be less than 40 degrees. So there are a set of cells which has to be met this criteria. So before going into the BMS and the batteries, once you take a conventional electric vehicle, you can observe here we have an either vehicle. So you can observe a few sets of functional parts in it. So the main, if we take the load as subaxial mount or hub motor, the load in an electric vehicle, the main load is the motor, infotainment, and the other power electronic devices. So the high power consuming load is the motor, and then comes the controller unit for controlling the motor, vehicle control unit to provide security and the interfaces, a battery unit, and a cluster infotainment unit, and also a telematics unit. So while considering this, you can observe there is battery unit here on the footrest. So let's see what will be there inside that. So on the top you can see gray color battery unit. In general, inside this we will have a set of cells, and the BMS unit will be there inside. So based on the design, the BMS can be inside, or it can be outside, or it can be on the vehicle body. So inside this pack, it can compromises of cell monitoring unit anyway in order to get the cell data. And the cell monitoring unit can communicate with the BMS unit on the vehicle body to get the cell data and to make our other estimations. So this pack has series of cells, rechargeable lithium-ion high-energy cells, see in different combinations of series and parallel. So let's go to what is a technical definition for a BMS. So this technology could avoid abuse and irrational use to ensure safety and to extend the life of batteries. So main criteria for a BMS is to avoid the abusive usage of a battery. So what is an abusive usage of a battery? How you can define the abusive usage? So how it has been defined? What is a non-abusive usage? So each cell from a cell manufacturer will be mentioned like it has to be operated at a given spec. Like it can be charged or discharged at a particular C rate. It has to be maintained in this temperature limit. So you exceed the specified limit, what would happen to a lithium-ion battery cells? Have you ever wondered? Yeah, these cells start to behave abnormal. You don't have any control over them because they are very high energy cells and they are all very compact. And once you consider the safety side, it is very less safer for the user to directly use a cell. So there should be somebody to monitor it, to parameterize it, to be aware of what is happening inside, and to communicate with the user or with the other electronic unit that you can charge this battery, you can discharge this battery. You have already met the charging limit, you can't charge it. It can communicate it, and it has to disconnect the battery from charging. While this, if the cell has already drained, it doesn't have any charge in it, and you want to discharge it, you want to go on for a ride, and suppose the charge is at only less than 5%, you want to go for a ride. So the battery, it can, without a BMS, it can give you the charge, but after it will be resulting in deterioration of the electrodes, positive, negative electrodes. So in order to protect from operating the cells at the lower voltage ranges and in the upper voltage ranges, we have to have a smart device or a controller unit for our cells. This BMS can prevent from non from abusive usages.